Now, as we go into topic 3 of Unit 4, we're using some other tools in mathematics, that is, permutations and combinations. Now, we'll give you a little background before we go on, but again, this is repetition. Now, we did factorials earlier, and the reason is because we use factorials in permutations and combinations. So the rule for permutation is the number of items you're dealing with permutated. You're going to select this many out of this total, and in a sense it would be the number of items you're dealing with, factorial, but now divided by the difference of n minus r, factorial. So this gets a little confusing to remember, and again, if you're using it all the time, of course that would be easier, but the key is, if something is a permutation, you would use this in your calculator. If it were a combination, notice that in the combination you're dividing what would have been in the permutation, this part, by an additional r factorial, the items that you're looking for. So in comparison, if you had the same amount of things, combinations are always much fewer because you're dividing that extra amount out of it. So permutations. Now you will, as you recall from the flipped classroom video, there are certain qualifications of whether you use a permutation or whether you use a combination. Now, repetitions are not allowed in either of these, but the significant difference is if order. Now, remember, we said that in the ordered pair, x comma y, order is important. We said that in sets, x comma y, order is not important. So here, if you reverse the order, that's a different item. Here, if you reverse the item, that's not different. Now, in permutations, order is important. In combinations, order is not important. All right, there's many more things that we covered in our class, but we'll move on. Now, as we do these, it is important that you know how to put this data into your calculator. So this first one is just exploring the use of your calculator. 7, finding permutation, clicking on that, and then putting in a 3, and then what does that equal? And that's 210. Let's go on. Now, in reading this, here they're asking you to determine whether the object is a permutation or a combination. Now we have a 10-digit telephone number, which includes the area code. So take a moment and keep in mind it may not be one of these, depending on the qualifiers of permutation or combination. Well, we said in both of these, repetitions are not allowed. In telephone numbers, you can have repetition. They are allowed. So this is letter C in this case. It is neither a permutation nor a combination because repetition is allowed. Let's go on. Now for number 3, a contractor is going to build 12 different models and has 4 lots. How many different ways can the arranged houses be? And we're saying 4 different models will be built. So repetitions are not allowed. So now you have to determine, is it a permutation or is it a combination? Well, the next thing is order important? Well, they're not saying it has to be built first on this lot, so order would not be important. So take a moment and tell me, which one would you use? Well, it would be combinations, and this is 12, and you are building on 4 lots. Now remember, because order is not important, we're using combinations. Let's see what you get for an answer. And again, you're putting this in your calculator to see if you get this value, would indicate you know how to do it. 495 arrangements. Let's go on. Now for number 4, we have a race, 8 cars. There are no ties. How many ways can the first 3 finishers come in? Now, repetitions are not allowed. Is order important? Yes. So we're going to have permutations. Now, what would this look like? Well, there are 8, and you want to select 3, and order is important. Put that in your calculator. Let's see what you get. 336 different ways to come in. So again, people buying tickets at a racetrack to gamble on the outcome, if you're just doing it randomly, there's a lot of different possibilities here. Now, for this one, it's a little bit tricky, so I'm glad I had an opportunity to go over it with you. Here, if we have a certain city where 6 streets are going north and south, so 1, 2, 3, 4, 5, 6, that'd be the black lines, and 5 streets going east and west, these are the red lines. How many street paths starts down here and end up there? Now I have found kind of a formula for this, and it looks like this. And this is worked out. So if there are 6 streets and 5 streets, take 1 away from each street. So 1 would leave this as 5. Take away 1 here, leaves this as 4. So this adds up to 9. So again, repetitions are not allowed, but order is not important. So we're going to use combinations, and there's a possibility of 9 that we've gotten from this formula so far. Now, we use the smaller number. In this case, it's 4. Put that in our calculator, and I have found this to be a way to figure out this type of example. So put that in there and see what you get. And you get 126. Now, when you get an example like this, this is the special hint I'm giving you in solving this type of example. How many streets, one way and the other? Take one away from each one. That'll be the total items for your combination. That'll be your n value. And then the smaller. Now, if it's the same number of streets, then you would just put one of them, which are the same. And again, if at first you don't succeed, try again. Now, as we look at example 6, here, skill and knowledge get to be involved, and definitely reading and rereading, coming up with a plan to see how this is going to work. So we know that in a radio or TV station, they need 4 letters as their call letters, so to speak. And in the first 2 positions, or in the first position, we're going to use a W or K. So here in a sense, a W or K. So there are 2 possible values that we can use there. Then, assuming no repetitions for the rest of these, how many 4-letter sets, keeping in mind W or K in the first position, and then using letters I to V? Well, there's I to V, and I counted 14. So how many are available for this next position here? 14. Now, how many are available for this next if no repetitions are allowed? 13. And for this, 12, because you are dropping one that's no longer available. So this is fundamental counting principles, and we're just going to multiply all that together, and let's see what you get. And I got 4,368. Now, as we do these, some of these get rather challenging, and you need to read it carefully, think, are we using fundamental counting principle? Are we using combinations? Are we using permutations? Are we using just plain factorials? Looking at this one, how many ways can 15 people be divided into 5 groups? And then respectively selecting 4 in the first, 2 in the second, 3 in the third, 1 in the fourth, and then 5. Well, repetitions cannot take place, so we're either going to use permutation or combination. Now, is order important here? No, this is sort of like selecting committees, just groups of people. So we're going to have 5 of these. 1, 2, 3, 4, 5. Now, and we're going to use combinations. So see if you can set this up, and we'll go over it. So we have 15 people first, so 15 combinations. We're going to select 4. Now, we're also going to multiply that by, again, all of these are going to be combinations. But now we don't have 15 people anymore. We only have 11. And we're going to select 2. So how many people to select from here? 9. and we're going to select 3. How many people from here? Well, now there's only 6. We're going to select 1. And then here, there's 5, and we're going to select 5. All right, let's put that in your calculator and see what you get. Now, it's a tad tedious putting that into your calculator, and you're just going to times all of these, of course. And again, knowing whether you're selecting permutations or combinations and following the protocol. So the strategy would be, again, it's combination. There are 13 clubs in a deck, so combination 13, and we want to select 3 clubs. So there's the 3 of the clubs that we want to select from the deck. Now, what's remaining? Well, we want to select 2 non-clubs. So if you subtract 13 from 52, you're going to get 39 non-clubs. There's my 39, and I want to select 2 of those. So for A, this is what the setup would be. When you put that into your calculator, this is what you get. And again, dealing cards, there's a great number of possibilities. Later, we'll be using some of this in our study of probability later in this chapter. All right, now let's take a look at B. It's done in a similar way. Again, you need to be familiar with what's in a deck of cards. Face cards. There are 12 face cards in a deck. So, combination 12. You want to select 4 of them. And then what is left? Well, 52 cards. We're left now with 40 that are not face cards in a deck. And we are to select one of those non-face cards. So putting this into your calculator, you're going to get this. All right, let's go on to C. And in a deck of cards, there are 26 that are red. So 26, combination, we want to select 3, times spades. There are 13 spades in a deck. Combination 1. And there are 13 clubs in a deck. We want 1. So putting that into our calculator, we get this. So these are rather challenging, and generally I'm not going to give any like this on our test, but you may get some challenging ones like this in your homework. In fact, this is from the homework. They just changed some of the numbers, but this is the protocol for doing it. Now, for number 9, as we look at it, it says how many different 3-number combinations are possible on a combination lock having 39 numbers. Now, they're giving us a little hint here, is that even though they're saying the word combination, in the mathematical combination, that's not what this is, because you have 3 slots here. This is, we're going to use fundamental counting principles. How many possible numbers can you have in the first slot? Because repetitions are allowed, order is not important. So this would be 39, this would be 39, and this would be 39. So in a sense, we have 39 to the third power, and try that, see what you get. Well, 59,319. All right, so that one was sort of easy, but possibly confusing. And for our last question, I think this one's a little bit easier. You have a race. There's 6 horses in the first race. So the chances of picking a winner out of the first race is 6. And then this is the daily double. There's 10 entries in the second race. Chances of picking the winner out of the 10 is 10. So in order to be sure you're going to have a winner of the daily double, how many tickets would you have to buy? Well, you'd have to buy 6 for the different ones here, 10 for the different ones here, for a total of 60 tickets. And each ticket costs, money. So the idea of luck and then knowledge, you can do some elimination. Again, I've never bet on a race horse or do much of this, but we'll be featuring this in future lessons. All right, and then my last little statement here that I have for you. Hopefully you're going to do a good job on this. There's just a few lessons left. In fact, there are just 5 lessons left. All right.